All right, in this video, we're going to talk about 3.5, Objective 5, where we find derivatives of products, quotients, and powers of functions with trigonometric expressions. Let's go ahead and get started. Our first function is y equals 6x to the fourth times sine of x, which is, I'm going to call that u times v. So my y prime is going to be u prime v plus v prime u according to my product rule. U is equal to 6x to the fourth, and v is equal to sine x. U prime will be 24x to the third, and v prime will be cosine of x. Y prime will be 24x to the third sine of x plus 6x to the fourth cosine of x. Okay, so that was a product rule example. Now let's do a power rule example. Y equals cosecant squared x. So this is the same thing as cosecant of x to the second power. So y prime is going to be 2 cosecant x times the derivative of cosecant as a negative cosecant cotangent. So that's going to make y prime equal to a negative 2 cosecant squared cotangent. And for the last one, for the quotient rule, y equals secant w over 1 plus secant w. I'm going to call that u over v. So y prime is going to be u prime v minus v prime u all over v squared. U is equal to secant w. V is 1 plus secant w. U prime is secant w tangent w. V prime is also secant w tangent w. So y prime is secant w tangent w times 1 plus secant w minus secant w tangent w times secant w over 1 plus secant w squared. So factor out secant w tangent w from the top, that's common. Get 1 plus secant w minus secant w in the numerator. That's going to give me secant w tangent w times 1 is secant w tangent w over 1 plus secant w quantity squared, like so. And there's no advantage to squaring that, so I'm going to leave that alone. Secant w tangent w over quantity 1 plus secant w quantity squared. All right, there's lots more examples of that in your book and even in your study plan in my math lab if you want more examples. But we'll come back next time and we'll verify statements involving trigonometric expressions. See you for the next video.